Okay, so question 6, the skater. I always like to have a little force diagram happening. So we've got our skater. The skater has a mass of 70, so there is a downwards force of 70 mg. And then we've got some resistive forces totaling 130. And if I take this to be a positive direction with the acceleration being this way, then those resistive forces would be minus 130. So I can use F equals ma to work out how long to stop it takes for the skater to stop. But in order to use suvat, I need the acceleration. I can find the acceleration by using F is equal to ma. So the total resistive forces is minus 130, and the mass of the skater is 70. So A would be equal to minus 130 over 70, which simplifies to minus 13 over 7. That makes sense because the skater's slowing down to a stop. So using that value of A, I can use some suvat. So using suvat, what have I got? I've got, I want to work out the time it takes. My acceleration is minus 13 over 7. I know that the initial velocity is 19, and the final velocity is 0 because the skater comes to a stop. So using V is equal to U plus AT, I can say that 19 is equal to 13 over 7 lots of t. This then rearranges to give me an answer of t being 10.2 to 3 significant figures. I need to work out the distance as well for part B. So working out the distance, I can again use suvat. V squared is equal to U squared plus 2AS. In this case, stopping velocity is 0, initial is 19, plus 2 lots of minus 13 over 7 S. S is then calculates to be 97.19, which is 97.2. Now, a lot of students in this question did not use an accurate value of A in order to work out their final answers, and lost some marks because they introduced rounding errors. For C, one limitation of the model, and there was lots of different answers. One of the limitations was the skater has been modelled as a particle, and we know that this is not true, so there'd be other factors including rotational forces that would affect the model. So particle, we can talk about rotation or forces. We can also say that it's unlikely that the total forces would remain constant. So the total forces would remain constant. We could also